Hello everyone, it's Metaclass here, and today I'm going to be showing you how to make a Tesla coil. But before building the Tesla coil, let's examine a few circuits. First, the Oscillator exciter circuit. This one works by current flowing into the transistor, and once the transistor has current applied to its base, it'll allow current to flow through its two ends, thus closing the loop and allowing current to flow through the first primary winding, which in turn powers the secondary winding. The secondary winding flows current to the transistor, thus combating the other current and turning it off, which in turn turns itself off. The power supply turns the transistor back on, and it is a self-regulating, self-resonant circuit. The problem with the last circuit, though, was that we cannot supply thousands of volts without having the transistor burn out. But luckily, everything in this circuit is unable to burn out unless it's supplied with ridiculous amount of voltage. So in this circuit, we have a high voltage capacitor, high voltage transformer, and a spark gap, which is represented by SG. At its core, this is a LC oscillator, and basically what happens is AC current will go into the high voltage transformer, and then once that voltage builds up enough, it'll spark the gap, which will then close the LC oscillating circuit. When the spark gap closes, the high voltage capacitor will release its energy into basically what is an inductor. Once the energy from the high voltage capacitor runs out, the magnetic field of the inductor will collapse, and in turn it will switch its polarity. The high voltage capacitor will charge again, and its energy will move in the opposite direction, creating a completed LC oscillating circuit. Okay, so let's start making it. I started off with 31 American wire gauge enameled copper wire, and a PVC pipe that I just picked up from a hardware store. Wrapping the enameled copper wire on the PVC pipe should take anywhere from 1 to 3 hours, but obviously you're going to take breaks, so me personally it took about 5 hours. After you have finished covering the PVC pipe in enameled copper wire, I'd recommend wrapping it in tape. After finishing the secondary winding, I moved on to the primary winding, which I personally use 10 gauge wire. You can use thicker or thinner, just make sure it's not make sure it's at least double your secondary winding wire gauge. And then I just added a tinfoil ball to the top. And the Tesla coil is finished. Now all I have to do is hook it up and test it. Here I'm showing you the Oscillator exciter circuit. This one supplies a good steady current. Not as high as a voltage, not enough to create sparks to your finger or to the ground or to metal or something. It can light up a light bulb better than the tank circuit though. Now a quick side note before I show you the LC oscillating circuit or the tank circuit. I want to show you how to change the oscillation speed or the frequency. So you can just change it by moving the spark gap further or closer together. Alright, so this is the tank circuit or LC oscillator. So this one personally has created high voltage for me, but not as steady of a voltage. Maybe it's just because I can't find the correct resonant frequency for the Tesla coil, but I haven't played around with it much, so I'll definitely possibly do another video in the future if it gets any better. In the Oscillator exciter circuit, make sure to put a resistor before your transistor. I used a 22K resistor before my TIP31C transistor. I chose the TIP31C mainly because it has a fast switching speed, but also is resistant to temperature and can hold high voltage and high current. And if you're using a 22A transistor, then you're definitely going to have a resistor that's above 100K ohms, that is. And yeah. Thank you for watching the video, and bye.